Okay, in this section we're going to be going through 2C, and that's going to be the second part of xt graphs as well as velocity. So the xt graphs part 2 and velocity. So the first thing to remember in this section is speed. Speed is how fast an object changes its position. For example, 2 meters a second is a speed. So if we have an object and it's moving faster, it's moving at a higher speed than an object that's moving slower, basically. So it's important to remember that speed does not have a direction, right? We see 2 meters a second. 2 meters a second doesn't specify whether that's up or west or north. It just says that's how fast you're going. It's just the rate. Now, a new idea in this section is the idea of velocity. Velocity. The symbol for it is little v. So velocity is how fast something's moving, so it's the speed, and in what direction that object's moving. So for example, -5 meters a second is a speed. The negative indicates the direction. So the negative would indicate which way that object's moving, and then the 5 meters a second would be the speed. Speed. So again, velocity is speed, how fast something's moving, and then it's combined with the direction. Another example would be 8 meters a second west, right? West is the direction, 8 meters a second is how fast it's moving. The standard metric unit for speed and velocity is going to be meters per second. That will be the standard unit. It's important to remember with xt graphs, if you have a linear or straight section of an xt graph, right? If you have kind of the diagonal like that, if you have a straight linear section, that indicates you're moving at a constant velocity. So if you have something like this right here, or maybe like this, that means that it's a constant velocity, that it's moving at one rate, it's moving in one direction. Now, if you instead have a curved section of an xt graph, that indicates an object moving at a changing velocity. So if you see something like this, like that, or like that, so that indicates an object moving at a changing velocity. Because the slope, if you look at the slope, it's changing depending on where you are in that graph. So that's important to keep in mind. Straight versus curved xt graphs. So now we're going to look at some common xt graphs, because xt graphs can get pretty complicated looking, right? It could have multiple parts, right? It could have several parts like this one. But it's important to keep in mind that xt graphs are usually going to be combinations of simpler shapes. So we're going to go through those simpler shapes now. Here we go. So with an xt graph, the shapes, these are the common shapes right here. The first one's zero velocity. So if you have a straight line like this, or a horizontal line, this basically indicates that, remember, steepness is how fast it's moving. So if it's level, it's not moving, it's standing still. Over here, this is a constant positive velocity. So it's positive slope, so it's a positive direction. And it is one basically slope. Any point along this line is going to have the same slope. So it's a constant positive velocity. This one over here is kind of the same thing. It's a constant negative velocity. So it's a negative slope, it's down. And if you look at any single point, all those points have the same slope. It's the same steepness this whole way. Now the next one, these are the curves down here. So these involve a changing velocity. So this is increasing positive velocity. So if we look right here, it's pretty level. And then as you keep going, it's getting more and more steep in the positive direction. So by the time you get up here, you're moving fairly quickly in a positive direction. This is kind of the opposite over here. So this is increasing but in the negative direction. So you start off level. Start off with really no slope, and as you keep going, you see that it gets steeper, 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 in the negative direction. So you have an increasing negative velocity over here. This one is a decreasing positive, so what you see is it starts out pretty positive, and as you keep going, it keeps getting more and more level. And then the last part is a decreasing negative velocity. So it starts out pretty negative, and as you keep going, that steepness gets less, gets less, gets less, gets less, until it's pretty much level at the bottom. So those are common shapes. If you see an XT graph, it's really going to be made up, most likely, most of the time, it's going to be made up a combination of these simpler shapes. So let's see a problem now, actually, with XT graphs and velocity. So this is an example of a problem you might get with XT graphs. So take a second to see if you can solve it first before I go through it. Again, remember, you're probably going to have to look back at the shapes that are on the previous page. So make sure you're solving it. Okay, I'll go through. So it's saying, let's sketch an XT graph for the following. We have a car moving to the left at a constant speed. So car moving to the left, constant speed. It then gradually slows to a stop. Gradually slows to a stop. And then it sits still for a few seconds. So this is it's looking for an XT graph. It might be helpful to draw what is happening. So the first thing that's happening, I'm just going to draw a box for a car. So it's going to the left at a constant speed, right, like this. This is the first thing, moving to the left at a constant speed. And then what it's doing is it's gradually slowing down. So not to it's slowing, 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 and then eventually gets to a stop. And then that stop position, it stays there for a few seconds. So that's really what's happening. It's moving to the left, gradually slows down, it's stopped. So again, we need an XT graph for this. So I'm going to draw that out. So XT, X again in the vertical, because that's position, T in the horizontal, that's time. So we need these three pieces to it. So the first part is left at a constant speed. If you flip back to the previous page, you're going to see, what does left at a constant speed look like? That's a constant negative velocity. So again, it's going to the left, and it's constant. So it's constant and negative. So we're just going to draw a diagonal line down. Diagonal, that's pretty good. Okay, so that's the first part. That's part one of the motion. The next part is gradually slowing to a stop. So what we have is a gradually decreasing negative velocity. So it's going to start here, and it's going to start leveling out until it gets to 0. So again, we're going to see the slope be pretty steep right where it is, and then kind of level out to 0. So we're going to draw a curve from here. Oops. Let's try that again. Curve, gradually slowing. There, that's pretty good. So this is part 2, so we see that it's actually slowing down. The slope is getting pretty much lines up to this, and it's slowing, slowing, slowing until it's pretty much at a stop. And then once it's at a stop for a few seconds, that's level. Level, there we go. This is part 3. So again, that's how to draw the graph, right? It's constant velocity, negative velocity, it's decreasing negative velocity, and then it's stopped. So those are the 3 parts to the motion. Again, it doesn't need to be super neat, but you do need to be clear about what sections of your graph are a curve and which ones are straight lines or horizontal lines in this case. Okay, make sure you have all of the notes and the problem copied down, and that's it for now.